Welcome to the next video in our trigonometry unit. We are going to introduce the unit circle. The unit circle is a circle of radius 1 that is placed on a coordinate grid or on the xy plane. If r is 1, then we can figure out what sine theta is, cos theta is, and tan theta is. I'm going to draw a little quick diagram on the side here. Okay, so this is our origin point. Let's just say that we have some point P on the unit circle, which means that we have a radius of 1 from the origin to that point. And then you can close it off and create our right triangle. I'll call the bottom here our x value and the height of the triangle y. So if I want to describe this as in sine theta, cos theta, and tan theta, sine theta we know is opposite over hypotenuse. So our opposite side is y relative to theta, and then our hypotenuse is 1. If we're looking for cos theta, our adjacent side is x, our hypotenuse is 1. Then lastly, for tan, we have opposite over adjacent. Our opposite's y, our adjacent is x. Another thing to note as we're looking at coordinates on the unit circle, every point along here will have a radius of 1. Whether it's from the origin to here or the origin to here, all this will have a radius of 1. So we're going to find the coordinates on the unit circle for each reference angle and its related angles in all 4 quadrants. So we have an angle, a reference angle is 90 degrees. It's located here. And this point specifically is going to be 0, 1. This is the point on the unit circle. Because our distance from the origin to that top is 1, and then our x value is 0. Looking at our next reference angle, this is 45 degrees, which is going to be approximately cut in the middle between 90 degrees and 0 degrees over here. We're going to have a point P here. We also want to find its coordinates. So I'm going to rewrite our information on this triangle here. So you know this is 45 degrees. Our radius is 1, and we need to find our x and y values. Looking at the x value, we can definitely solve for this if we use cosine, because cos 45 degrees is adjacent over hypotenuse, just as stated like above. And then we can solve for x. So x is cos of 45 then, after I multiply both sides by 1. If you insert this into your calculator, it's going to be 0.707 and a bunch of decimals. And if I wrote this in radical form, it's actually going to be root 2 over 2, which is equivalent to that. And I would just rather you remember this root 2 over 2, because a lot of the times when we're going to utilize the unit circle is it's non-calculator. To solve for y, we're going to do the same sort of thing, but we're going to use sine in this case. And then sine 45 is also 0.707 and a bunch of decimals after that, which is equivalent to root 2 over 2. So my point over here on the unit circle then is positive root 2 over 2, positive root 2 over 2. And writing it this way is more accurate than writing its decimal form. We also want to find its related angles. So the root 2 over 2, root 2 over 2 is also good for other angles, and we'll just rewrite it in other quadrants. That has a 45 degree reference angle. So this point would be negative root 2 over 2, positive root 2 over 2. And we can also have one in quadrant 3, which would be negative root 2 over 2, negative root 2 over 2, and lastly also in quadrant 4. We're going to get root 2 over 2 minus root 2 over 2. And if you wanted to find the angles that have these reference angles in quadrants 2, 3, and 4, for quadrant 2, you would just make the calculation of 180 minus 45 degrees. For quadrant 3, it would be 180 plus 45 degrees. And then in quadrant 4, it would be 360 minus 45 degrees, which is what we learned from our previous lessons if you want to find the angles that have the reference angle of 45 degrees. We're going to do the same sort of thing, but look at the reference angle of 30 degrees now. So this is approximately 30 degrees. We're looking for some point P. We know the radius is 1. I'm going to rewrite this information on that right triangle that's given to us. And we're looking for those x and y values, so we know the coordinate points. So x is calculated as cos of 30 degrees is equal to adjacent over hypotenuse. And cos of 30 is 0.866 and a bunch of other decimals, but this is equivalent to root 3 over 2. Then we're going to do the same thing, but for y, which is sine 30, is opposite over hypotenuse. Sine 30 is 0.5, and we can rewrite this as a half. So our coordinate point then is root 3 over 2, a half. And we can have the same sort of reference angle in quadrants 3, 2, and 4. With similar points, but it'll be in its respective quadrants. So we're going to have negative root 3 over 2, a half, negative root 3 over 2, negative a half, root 3 over 2, negative a half. And if you want to find the corresponding angles that have these reference angles for quadrant 2, it would be 180 minus 30, which is 150. For quadrant 3, it would be 180 plus 30, which is 210. And then for quadrant 4, it would be 360 minus 30, which is 330. And then the last one we're going to look at is 60 degrees. Okay, and then I'm going to write this onto our triangle and solve for x and y. So to achieve x, we're going to use cosine. Cos of 60 is adjacent over hypotenuse. Cos of 60 is 0.5, which is a half. For y, we'll use sine, which is opposite over hypotenuse, and sine of 60 is 0.866 and a bunch of decimals, or you can rewrite this as root 3 over 2. So then our coordinate points are going to be a half root 3 over 2. And we can find similar triangles in other quadrants by using the same reference angle. But our point here is going to be negative a half root 3 over 2, negative a half, negative root 3 over 2, 1/2 root 3 over 2. And then lastly, we can state what angles would have this reference angle. So for quadrant 2, this would be 180 minus 60, which is 120. For quadrant 3, it'd be 180 plus 60, which is 240. And then lastly, for quadrant 4, it would be 360 minus 60, which is 300. Now we're going to look at all of this information put together. So this is if I took all of these unit circles that I drew and then placed it right on here. And this is what it's going to look like. Do you need to memorize this? I mean, it would benefit you, but I can show you some shortcuts instead of memorizing this huge unit circle because it is a lot to memorize. But you don't need to know radians for now. You're going to learn that in grade 12 pre-cal, so just focus on the angles that you know that are in degrees. So my shortcut here is we're going to remember the triangles instead, the ones that we drew in here, those triangles, and replace them with those x and y's. So here's one triangle where we had 45 degrees, and our sides are 1, and the hypotenuse is root 2. Equivalently, you could also memorize this one. Which is root 2 over 2, root 2 over 2 for the sides, and a hypotenuse of 1. So either of those are fine. So this is one that you need to know. The second one is the 30-60 triangle. Okay, so the side that's directly across from 30 is 1. The side that's directly across from 60 degrees is root 3. And then your hypotenuse is 2. Or you can remember this one as well. We can have a hypotenuse of 1. The side that's directly across from 30 is 1/2. The side directly across from 60 is root 3 over 2. So those are the two triangles I really want you to memorize. I usually don't like students to memorize things because I want you to understand it, but in this case it does speed up the process a lot more if you do have them memorized. And it's also going to help you in grade 12 pre-cal because we'll be using these special triangles over and over and over again. So those are the two triangles I want you to remember. The other thing I want you to remember is the main parts of the unit circle where we have 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Because then we can tell what sine 90 degrees is, cos 270 degrees is, and so on. I know you're running out of room here, so I'm going to write it down here as a third thing you need to remember. So here's our coordinate plane. This is our unit circle. There's coordinates of 1, 0 here, 0, 1, negative 1, 0, and 0, negative 1. It's important to note these because we can determine cos of 0 degrees or sine of 90 degrees and so on. Because a rule is part of the unit circle that the first coordinate x is cos theta and the second coordinate y is sine theta. Why is that? We already determined that all the way back here. How do we determine y? Y is equal to sine theta. X is equal to cos theta. So once I apply that on the unit circle again, I am still going to get coordinate points. To get x is going to be cos theta and y is sine theta. Now we're going to go ahead and fill in this table using our triangles and the partial unit circle. So if I'm looking for sine 0 degrees, I'm going to look at part 3, and I'm looking at the second coordinate of where 0 degrees is. So 0 degrees is here, and I'm going to look at the second coordinate because that's where sine is, and that would be my answer. So sine 0 degrees is 0. If I'm looking for cos 0 degrees, same thing, I'm going to look at the 0 degrees in here, and I'm going to look at the first coordinate instead now, because that is where cos theta is, and that answer then is 1. Then lastly, for tan theta is defined as sine theta over cos theta as an identity. So then sine theta then is 0 over 1 by using the information we just found above, and this is 0. So tan of 0 degrees is 0. Now looking at sine 30, I'm going to look at part 2 here for my triangle. I'm going to look at the 30 degrees and look for sine 30, which is opposite, and that's 1, over hypotenuse, which is 2. Then I'm going to look at the 45-degree triangle. You can use any of the 45 degrees no matter which one, because you're going to get the same answer anyway. So opposite is 1, hypotenuse is root 2, or if you use the other triangle, you're just going to get root 2 over 1, which is just the same thing, root 2 over 2. These are the same thing, your denominator is just rationalized. Then sine 60, we're going to use triangle number 2. Across from 60 degrees is root 3, your hypotenuse is 2. Then lastly, we're going to look for sine 90. At sine 90, we have the point 0, 1, and sine is the second coordinate, the y-coordinate, so your answer there is 1. Now we're going to move on to cos. So cos of 30, we're going to use our second triangle. Cos is adjacent over hypotenuse. The adjacent side is root 3. Our hypotenuse is 2. Then we're going to use the 45-degree triangle. Our adjacent side is 1. Our hypotenuse is 2. Equivalently, you could use the other triangle and it get root 2 over 2, and that's fine. For cos 60, we're going to use the second triangle. So the adjacent side of 60 degrees is 1. Our hypotenuse is 2. And lastly, cos of 90 degrees, we're going to use our third piece of information. At 90 degrees, we're going to look at the first coordinate, which is over here, because that's where cos theta is. So cos 90 is 0. Now we're going to use the rule for tan theta is sine theta over cos theta, and I'm going to use the information I already found. So this is this is a half then divided by root 3 over 2, which is equivalently 1 over root 3. Then for the 45-degree one, it's going to be 1 over root 2 over 1 over root 2, which is just 1. For 60 degrees, it's going to be root 3 over 2 divided by a half, which is just root 3. And lastly, 1 divided by 0. We can't divide by 0, so this is undefined. Before we move on, I'm just going to end this video right here because I do want you to practice the unit circle as much as you can before we move on, because it does get more complex from here. The first thing you need to do is remember those two triangles and that smaller version of the unit circle, and practice them again and again using those reference angles to find its exact value. So I'll give you a worksheet to practice that, but do prioritize to remembering these because you will not only see them in grade 11, but you are going to see them in grade 12.